Hey everyone, welcome to this month on consumer electronics. I'm Brian Tang. I'm a senior solutions architect based out of Boston. And Chris?
Yeah, and I'm Chris Sordin, also a solutions architect on Brian's team, based out of New York right now.
Yeah, and just some background on the show. We work with a lot of different customers in the high-tech electronics space. So a lot of consumer audio, maybe batteries, TVs as well. And we want to take what we learned from working with customers in the field and use that and teach the audience a few things about how AWS can bridge from the physical world into the cloud and vice versa.
Yeah,
Yeah.
yeah, we've if you've joined us in the previous few episodes, thanks for welcome back. If you're new, glad to have you. But first couple episodes, we really dived a bit into bringing these smart devices to earth in terms of like whether you're trying to build out your own smart home or trying to build out like a smart fridge. There's ways in which these are ecosystems where we want to be able to make sure that we can have them talk to each other, have them sort of meet your overall needs from a smart home perspective. So yeah, where's everyone joining from today? Feel free to put where you're joining in on in the chat.
While we're doing that, I'll pull up what we've been working on. So I don't know if you can see this clearly, but let us know if not. What we did in the first couple of shows was do a little bit of system design, try to illustrate what are all the different components from the edge to the cloud. Chris, you can give a recap if you want. I have a
Yeah, sure.
memory.
Yeah, we went through this in depth last time. If you wanted to rewatch the recording, but yeah. So, generally speaking, we already discussed sort of functional requirements of the types of systems within your house that you would want to be part of this smart home ecosystem. But last episode, we went through what that actual entry point looks like from a mobile app perspective, right? These are the first touch points for you to be able to set the temperature. First touch points for you to be able to lock doors within your overall application, right? These are the things that we are used to and accustomed to when we install our smart home devices, right? So we have discussed how there is an authorizer, sort of a gateway in terms of how the mobile application is actually talking to the logic of the application. From there, how it's storing the data, how you're able to make certain requests, certain messages that you want to be able to do the things you wanted to do, whether it be close a garage based off of certain criteria or based off of like a certain criteria, as I mentioned. And then also we had discussed in terms of like where that overall streaming and IoT type of flow comes back into that overall logic. And as well, we dived a bit deeper into the types of notifications that you can be able to get based off of a certain criteria for you to be able to be alerted back on the application itself. Right. So definitely a great episode, but for now we're going to be going more into more of like the certificates and how it actually comes to be to actually register these devices onto this sort of ecosystem.
Yeah, I mean, we talked about a lot of the really fun stuff of having an application where you can control everything in your house, set environments and things like that. And we also talked about on the other end of the thing where if you're not like an enterprise, you're just a person with a smart home technology and you're registering devices into a local hub. You might not necessarily see what's happening down on the platform side. And we had talked about that as well of like, okay, if you're an enterprise, this is how you're able to handle millions of devices and collect the right information to improve your products for the future for people. One of the things that we skipped over was how do you establish that connection in the first place? And that's what we want to solve today, or not solve. It is solved, but we also want to talk about some of the nuances of how onboarding happens. I guess the word is onboarding.
Yeah.
How do we onboard devices? And is there anyone in the audience that has onboarded devices before? Opened a box of a speaker and then had to download an app, or opened the box on their smart fridge and had to scan a QR code on the I guess on the box or on the device itself. Usually it's on the device itself.
yeah, feel free to make this interactive, but put your comments in the chat. And
Also going to put on some lo-fi. Set the mood for a chill.
oh yeah, this is great.
Okay, so how do we onboard devices? To make all of this stuff possible, getting the devices to get their telemetry data into a platform, or on the other end, being able to connect to an application where you can control your devices and like create environments, we have to do something first, and that something is what I want to cover in more detail today. So let's create a new slide, and let's draw it out. And one of the first things that you might be thinking about is there might be a couple of ways, like where does the onboarding process even start, right? In a lot of cases, it starts in the factory itself. So say you're a smart vacuum company, right? And you have robot vacuums. One of the things you might do at the very beginning is you have to bake in some permissions into on the manufacturing floor itself into the device. And what that does is let you set up in the future, somebody opens the box and then they're able to register the device. And then now you can trust the device and have communication in two ways. One for command and control of the robot vacuum, but also in the future, you want to deliver updates to the vacuum. Your team is going to figure out ways to make it more secure, or you want to add more functionality to the vacuum. One specific case was, if it's poop, don't run over it. That's a good one. And that wasn't something that they had thought of in advance. So in the future, you want to be able to avoid poop. So you gotta update your vacuums to be able to understand that. Okay, so how might I represent this? Let's say we have a device, and I'm just gonna copy from my PowerPoint folder. And in this case, let's keep going with Chris's smart lock example. You have a smart lock and you manufacture it, and it needs something in the future that we can use to establish a connection. And there's two main ways to do this. I guess you can call it the lightweight way and the more pre-provisioned way. So the lightweight way would be, I give you something that's closer to bootstrapping the device. It's the minimal amount of permissions I need to establish that this device has its own identity in some way that I trust. And then what will happen is there will be sort of a flow where you trade certificates and then you establish a more formal connection. So it's kind of like having a temporary working permit and then you're exchanging it later on for a more official passport type of thing. The other way is pre-provisioning completely. So not only am I giving it all the keys it needs, but then I also set up the device on the AWS in the cloud side, and I understand that it's mapped to something in a database somewhere. And that's a little bit more heavier. So just to keep things simple, we'll bootstrap in this case. So what you're doing when you're bootstrapping is you're giving it let's call it a bootstrap certificate for now. Ooh, not all caps. Who likes to type? Who likes to type in all caps? You can put it in the chat. And
don't be scared of the chat, everyone that's listening. And if you have some comments or questions, feel free to put your comments in the chat.
And I'll call this the smart lock. Put it at the top. I mean, who in the audience has manufactured something before? Let's see. It's quiet today.
Yeah, it's very quiet today.
It is Tuesday. It's Tuesday, right?
Yeah.
Okay, so what we need to do is to onboard this device. So what we've done at manufacturing is we baked in this private key, and it is signed by somebody called a certificate authority. Either you have your own is some sort of trusted party that signs it and is generally trusted. And this is how you're able to establish trust in a lot of ways. I'm oversimplifying it a little bit, but I don't want to go too into the weeds because there's quite a bit of depth you can go there. But just know that typically when you're given a certificate, it's trusted by a bunch of parties. And we said that this is a Bootstrap certificate, right? So it's not like the thing that we're going to use to directly communicate with IoT core in the cloud. So I just want to make a box to represent the cloud side. It's going to be a big box because there's a lot of stuff we want to talk about today. And let's say no fill. Okay. And the text is white, so I can't see it. All right. And let's put it at the top. Okay, great. Now we have the cloud side. And what we mentioned was that when you open up the box and then, you onboard a device, you usually have to install an app. So, I mean, Chris, have you recently done something like this?
Yeah, I recently got Echo devices. You always have to download the Amazon app, or there's always an application involved when it comes to any sort of smart TV type of appliance that I need. So yeah.
I know Christy also had Echo as well. I haven't turned my house into a smart home yet, but I'm going to. So this is actually a good framework for doing that. All right, so let's just represent the app here in the middle, and let's say core app, because we called it the core app before, and we're going to use it to complete our registration process. And what does that entail? Okay, so we said that the Bootstrap cert is not enough. It was signed, and it has usually you have a root certificate, but then you have intermediate certificates as well associated with it. And the reason you might have those is because you might want to revoke it in case you run into some situation, and you don't necessarily want to be using the root certificate, because if you have to revoke the root certificate, then it becomes more costly to replace things. Whereas with the intermediate certificate, you can it's a bit more flexible. So what we do is, once we connect via the core app, we're going to connect to, say, IoT Core, for instance. And IoT Core, I don't know if you have the documentation for that, is a core IoT service on AWS. Wow. It's a great name because it does a lot of things, right? And we're going to cover what all those things are. But one of the things it can do is help you with this onboarding process, right? So it'll have an endpoint that the app is aware of, or the device is aware of in some cases, and is able to send this request over to that endpoint, and it's authorized to do so. I need an arrow. Okay, I used to be a consultant, so I like to make things align. Don't hold it against me. Okay, so let's just add a note for people that are coming in. That's not huge. But we're sending this Bootstrap cert, which is signed, and we're sending it with a certificate signing request. So we're trying to get a real passport, so that we can establish more long-term trust. And then IoT Core is going to send something back. And what is it going to send back? It's going to send back that passport. So it'll be an official cert. And what it will be is, a private key. And they usually call it X509. You may see this a lot. And it's just a fancy word for a wrapper around certificates. It's an abstraction. So what are you going to get back that you're going to use? You're going to get an official cert. That's the green thingy. and then we get a private key. That'll be the red thingy, and that'll be, and then you'll get a token to use to activate, which is going to be used to activate the cert.
Yeah, a good way to think about this is, IoT Core is really acting as that, like a digital doorman, being that, touch point to be able to make sure and authenticate, make sure that the device can be authenticated properly, and then provide the returning certificate, a private key back, right? Before it actually even does any logic behind the scenes.
So yeah, there's stuff being processed. What also happens is, once you get this, the device will actually store all this key information into like some sort of secure storage. So when I think about it, like, yeah, your smart fridge or your Echo or your smart lock, if it's smart enough, it should have this space allocated to store your private key and certificate. And now what you need to do is you need to make sure that this device is also represented and known in the cloud, because what we talked about earlier, like, why do we onboard devices? Well, we want to make sure it doesn't run into poop when we figure out how to do that. And we also want to, make the connection, make the secure connection, so we can get the telemetry data. Lets us improve the product. All right. Any questions here?
Very quiet crowd today.
All right, so let's say we've gotten this key. Now we need to provision. Hey, Yokai Artist, is that how you say your name?
Welcome, Yokai Artist.
Maybe you can help us draw this. I wish I could figure out a way. My art is not the best. I'm trying to get the concept across, but maybe it could be improved.
Yeah, this looks great. I definitely see the consultant in you coming out right now. So great job so far.
Oh no. All right, so we want to publish some params. We have some sort of hardware secret, an ownership token, stuff that proves that we're allowed to connect to the cloud. And like, what did I say? Oh, right. So firmware updates. So why do we onboard onboard devices? Well, we want to be able to give it updates. The other thing is we can also track, we can track the state of things. And then that's going to go into the topic of like, oh, how do I represent my Echo in the cloud? And then not only do I want to have a record of this is the ID of the device, it belongs to Chris, and other more static things. There's also something called a shadow. And what that does is it allows us to understand what state we wanted something to be in and what state it is in. So for example, a shadow, a good representation of that would be a light, right? I set it to red. My desired state is red, but right now it's orange. So I should do something with that and make sure it's red. And so things like shadows let you understand that type of data. Other important things would be temperature, right? So my desired state is 72 degrees and right now it's 89. So if you want to kick off some automation to get the temperature down, and then once it's at that right temperature, then we can stop and save some money. Okay, but how do we get to that point, I think is the big question. So once you're able to make this second request with this more passport-y information, there's something that you can execute called a provisioning template. So consider this automation that you can run. And there's additional things that you might want to do using Lambda as well to there's always like sharp corners of automation that you want some flexibility with, and having Lambda functions help you do that is really helpful. So what do we call this? I want to make sure I label this well. Oops. AWS OT core run provisioning template. How's that look?
Looks good if I zoom in all the way on my side, but
I'll make it bigger. There we go. Okay. And what we're doing is we want to activate things, and we want to be able to set up our little cluster of things. So in this case, we just want to make sure that we represent our thing. We have a certificate and we have a policy. I just stole all those off PowerPoint. And this is kind of what I was mentioning. Like, a thing is the cloud representation of this smart lock that we have in our home. And then it's going to have that IoT certificate, and it also has an IoT policy. So like with all things in the cloud, policies are really important. Like, what are you allowed to do? In this case, we want to make sure that this device that we have can only do a few things. And it looks like this. It looks a little complicated if you don't look at JSON all day, but it's pretty straightforward. So in this thing, it's basically we're saying this device is allowed to connect as long as it has this thing name. It's also allowed to subscribe to a specific topic, and it's able to receive messages from a specific topic. So very, very bare bones policy example here of like what this particular device is allowed to do. And once you have this connection, this representation up and running, a lot of things you can do revolves around like setting up topics, which is essentially just a place where devices can listen for things or publish to. Or on the cloud side, there's some things you want to publish to, and the devices are listening for those so that they know what to do next. And this is going to be, I think this could be more tangible once we go through like a firmware update process example.
Yeah, if you think about it, like if a firmware update were to fail, then we want to have an event that's listening for that, be able to go about that in some sort of way after it fails, to be able to either retry it, redo it. So that's very important in that overall step.
I mentioned there were a couple different there's a couple different ways to do this. Like, if you think about it, there's the Bootstrap way, and then there's like a heavier way where everything ahead of time is known. So some companies, like say some robot companies that do like vacuums, for instance, might take the approach of, okay, at manufacturing time, I want to make sure all this stuff is like set up ahead of time. I want to make sure that the devices are mapped already to like things with certificates and policies set up. And that's like the difference between pre-provisioning and the Bootstrap approach. I think for the most part, if you think about it, this Bootstrap approach is more common for a lot of consumer products like smart fridges, like light bulbs, and other things. But you may want to have that like fully controlled pre-provision process for more industrial equipment or like vehicles or something of that nature, something that's like a lot heavier, where you want more control and you want more things known ahead of time. But in this case, like, it would just add, say, an extra arrow here where when you're provisioning, you're leaning on stuff that you already know and you're probably already tracked in a database somewhere. And in this case, it's DynamoDB. Who's worked with DynamoDB before?
I have. Hey, Jignesh, thanks for joining from India. Feel free to add to the chat if you have any questions as we go through this. But welcome.
Something I didn't call out here was that, yeah, there's that provisioning endpoint that you're aware of. Either the app or the device would be aware of this endpoint to like kick off this whole process. And you only have access to that endpoint. Okay, and yeah, that's like the basic gist of it. If you want to read more, you can go to the IoT white paper, which, do you happen to have that ready?
Let me get it.
Yeah, and like once you have established this sort of handshake, a lot of communication will take place after. And that's that. I'm trying to think of what else we might want to talk about here. The onboarding piece. Yeah, I mean, we talked about the QR code scanning, like what's actually happening. When you scan the QR code, you're basically taking this physical device and you're linking it to the cloud, and it kicks off all this setup stuff that we talked about. And what is a QR code? I mean, in the last show, when we shared some white papers, we kind of shared them as QR codes themselves. And QR code is just like, we're encoding a bunch of things and we're exposing it in a way that makes it easy for you to process it with a camera. In this case, what we're going to be encoding in the QR code for this device is the things like the device has a serial number is going to be really unique. So we want that. There might be like a unique setup code. And even the public key that is part of this device, in this it's a public key fingerprint, and even the one-time bootstrapping token. So all of that bundled together helps us reach the point where we can provision the device into the cloud and also get the stuff that we need to be able to communicate with the cloud safely long term.
We have a question from 1C.
Yes.
Is it possible to rewatch the stream later? Yes, it is.
Yes. I don't think we'll have the link until after the video is up, but I don't know. Maybe the producer can help us out with that. But there is a YouTube channel where all the videos are posted. So I don't know, Chris, maybe you can find the YouTube channel where our videos are posted and just share that.
Yeah, I'll definitely get that over. I'll get that right now, actually. So you can watch Brian and I talk in the other 2 episodes as well if you want.
Yeah. I mean, the benefit now is you can ask us questions now. You can ask us anything. And we'll do our best to answer. May not have all the answers, but we'll try. Okay. All right. So we also want to talk about firmware updates, but I want to make sure that I haven't missed any information that people might be wondering about. All right. It seems like nothing is the matter, so we can move on. All right, so we finished this. Let's just note this. Done. We kind of covered this at a high level. Why do we onboard devices? Halfway. We're here. We are tracking firmware updates. Okay, so you want to beef up your robot vacuum fleet or your drone fleet with fresh updates. What do you need to do? Well, we know that we've established this connection so that we're able to talk. So let's represent this again. So we want to make sure that we have a good process for getting updates to our fleet of blocks. So the first thing we do is, there's usually a team that'll create the updates. I am not on one of those teams. I've never been an embedded systems engineer. but I have worked with teams that do it. For now, we can just treat it as a black box, but we're the cloud architects, so we're going to try to give them the infrastructure they need to do the really important stuff that they have to do, which is make sure that this code can go out to millions of devices reliably, and have a way to store it and deliver these updates efficiently. So maybe it's worth writing down what we want. Scale to millions of devices. Have a maintainable process. What else can you think of?
Feedback loop for fine-tuning the product even further.
Yeah. And maintainable process is kind of a loaded cover all. So like you need to know a few things, like let devices know when an update is ready. And we have to know when updates have been delivered. I think that's important. And something I hinted at was topics are a great way to help us organize this. So the first thing is when you create the firmware, you should make sure that it gets to some sort of storage. And very common pattern for storing and serving the firmware updates, which is going to be some sort of file or a bunch of files, is S3. I'm looking for S3. Give me a second. All right, this is kind of a chunky diagram, and I'm going to steal an arrow from the previous slide. All right, so pretty easy. But there's something else that sometimes you have to do, which is how does the device know that this firmware that I'm delivering is the right one? Or like, how do I know to trust it? And sometimes what you can do is you can sign this firmware update. And we have a service for that as well. So we have AWS Signer. So we can kind of interject this here and say, like, we have the firmware, we're going to sign the code so that these devices trust it. And then eventually the devices, when they know about this update, they're going to like look at it and try to understand if this is something that they're allowed to download. And one of the things that we mentioned like a couple times already is that usually you need some sort of certificate with some keys in order to sign. And in this case, we probably have baked a key into this smart lock. And what we could do is like take that key, import it here into the certificate manager in AWS. And then these two are pretty tightly integrated. So you can use that key that's loaded up in certificate manager, and then use the AWS Signer service to sign the code. And now you've got your signed firmware code that's sitting in S3. And it's waiting to be delivered to millions of customers whose vacuums they hope to avoid poo from now on. Okay, so yeah, any questions about that?
No questions.
What about you, Chris? Do you have questions?
Let me think. On just signing in general, or anything?
Yeah, about this, or maybe anything we talked about earlier about shadows or like devices, things.
None so far. Just wanted to mention that these former updates, we take them for granted when we just do update on our application. But if it's an improper firmware update or something was changed in the overall process that could affect vacuums doing one thing that we don't want them to do, this can go really wrong. So this step is very important to make sure that we actually trust the actual update itself, and the person that's looking to authenticate can be able to actually make that update. So very important step that I'm glad that AWS has all these services embedded into it to be able to make sure that everything is smooth throughout this whole process.
Okay. All right. Yeah, I mean, and I feel like sometimes I have unfair expectations for like when I have a tiny firmware update, and then these enterprises are able to quickly roll out another one, and there's actually a lot of stuff going on under the hood. So it's good to know about these things. I don't know if anyone here is planning to start their own smart products company, but this is good to know if you're thinking about that. Okay, so what have we done? We've created the firmware stuff, we've signed it, and then we've loaded to S3. So how does our device know when it's allowed to get the update? All right, I'm going to use numbers because I think things will start to get more complicated, but it's not that complicated. All right, so what we want to do is we want to make sure that our updates can get out. And one good way that we have to do this is something called AWS IoT Device Management. So why is this important, and why would you consider using it? Because we said, if you've got millions of devices, what are you going to do? You dump everything into one S3 bucket and hope everybody downloads it? That's probably not the right move. You probably need some sort of orchestration. So maybe you say, I want to go 5% of devices at a time until I've covered all the devices. What else? I want to be able to handle when things fail, and I don't want to code it myself. I want to query all these millions of smart locks that are out there and see how they're doing in terms of like firmware updates, like which ones need it, how many of them tried to get it, and how many of them failed, and what can I do to respond. So like that's what this particular service helps us do. And so when we want to release firmware updates to these devices, we want to make sure that we create something called a job that can help us do this. And I think I can find this. So we have this job, and the job, once it's set up, is going to hit some sort of topic. And this is all within the IoT core family, I guess, is what you could call it. So I'm just going to put this underneath. And we're going to publish to some sort of topic. I think there's a specific name for this one, for this particular topic. But the main idea is you're just letting the device know, hey, there's a job for you. You have a job. You're employed. There we go. And your job is probably going to be, you need to do something. So like once you're aware that you have a job, you go to another topic actually. And I need a curved arrow here. You go to this other topic to start the job. So you want to get the job. You want to get the job doc that has all the details of what you need to do. And that is what you're going to do. And you're going to get it back from this topic. So this one is just like a request response. So let me just write it out here.
Great. You're doing a great job, Brian. A lot of great multitasking going on here. Talking, drawing. Really great.
I think it's interesting when you're kind of doing this on the fly. What I didn't do here is keep the numbers going. So I just want to make sure people aren't confused. 3, the job, send something to a topic. The topic, this device is listening, and it now knows it needs a job, and it goes to this other topic in order to get the details of the job. Why would you separate all these responsibilities? I don't know, Chris, do you have an answer?
Yeah, it's very similar to why you would want to modularize the application, right? So there's less dependencies on, so you can scale every topic without having to scale everything pretty much. So like scale every topic independently and be able to handle any troubleshooting independently, right? So it's very easy to be able to scale.
Yeah.
And, yep.
Yeah. So like if you have a job, whatever happens, fails, you can kind of identify that. It's like, oh, this specific thing is not working. I can update here. And you're kind of like breaking out the logic into different pieces. It'll make it easier to debug. And in this case, I'm like, oh, I know that the smart lock knew that it had a job, but then for whatever reason, it didn't try to initiate the job. It did, or maybe the response of like how you can do your job didn't get to the device. And that's like a separate breakdown. And like the more steps you can decompose the process into, the easier it makes to troubleshoot. And this
is very similar to just building out an application, right? You don't want to have everything on one server. You want to be able to break them down into composable steps within the application. So it's very similar concepts to what we're seeing here.
Yeah. It's so interesting that like a lot of principles don't change across different use cases or
for sure
aspects of engineering. Now you download from S3. And last step, again, on the debugging journey, let me just add one more thing. This is 8. Okay. And then the job's not done after you've downloaded from S3. It's like, I guess an analogy would be, the teacher gives me an assignment and I got it, and I just never let them know that I completed it.
Yeah, so we have a question from Killswitch 0007. What exactly is our AWS IoT Core here?
So IoT Core is the main IoT service, and it has a lot of capabilities there. So like being able to set up the jobs, being able to view all of the device shadows as well, like all the representations of the current state of the devices and things as well, the representations of the devices in the cloud. It also is the place where you may be setting up all the topics. So the realistic representation of IoT Core would probably be like
it's doing a lot.
So
a lot of heavy lifting for sure.
Yeah, I was just trying to keep it like here as a reference of like this is it's there under everything. I guess we could go into the console and look at it.
But thank you for the question. We also had another question from Bevan Viduli. Would love connecting where the updates are coming from.
Oh, what do you mean by that?
Yeah, are you referring to like firmware updates or what types of updates are you referring to?
I guess I didn't draw the box that represents the cloud. Here we go.
While we get a response back from Bevan, we have another question from
For the smart lock.
Yeah, for the smart lock, would you use Arduino or Raspberry Pi or something else?
So there's a lot of commercial smart lock solutions out there. So when I was talking about it, that's what I was thinking about, is like you have the device that has all those keys baked in. It has the associated app that you scan, and then it kicks off this provisioning process. If you were to roll your own, you would have to put that together yourself manually, right? So like, I don't know how I would turn a Raspberry Pi into a lock. Maybe I have some sort of, I'd have to build my own mechanical design and then have some sort of control that just like pushes the lock closed and unlocks the lock.
Yeah, that's That's a great experiment if you're actually looking to build, use either Arduino or Raspberry Pi. It seems like that could be a good thought experiment to see how the connectivity would work and what would be a sort of simpler in terms of some of those basic lock functions versus something out of the box.
Yeah. How would the lock communicate with the microcontroller? Well, that's a thing. I haven't designed my own lock, so I don't know how I would do that. But if you're trying to have like devices communicate to each other, we can think about maybe having a broker that can do like some local control. So like maybe you're not super dependent on the cloud, but there's ways of like getting devices registered within some local broker that you can work with. Like Greengrass is a good example. If you have a strong enough, like for example, a Raspberry Pi device, a lot of them are powerful enough that you could install Greengrass on them and then start thinking about, okay, how would I roll my own broker? And there's a lot of components that can go in there. Like I need to maybe handle the different ways that devices are able to talk. Some of them use Bluetooth. Some of them now follow the Matter protocol, which is like this trend of trying to establish more interoperability with a lot of different devices. But then they talk with different protocols, right? Some of them only talk over Wi-Fi, or some of them talk with Thread, or some of them have Thread. They talk with Thread and Wi-Fi. So then you have to do a lot of customization on that broker to be able to handle all that communication. But Greengrass does help you get there. Maybe we can dive into that actually.
Yeah. Right now or in a future episode?
Oh wait. Well, we've got 12 minutes left, so I wish I could. But a firmware updates repository? Yes. So Bevan, have you worked with firmware before?
Yeah, he's familiar with. That's Bhavesh had mentioned firmware over the air, FOTA.
Just looking at the comments.
Yep.
Oh, OTA, firmware over the air. You can deliver firmware over the air. So I'm aware if you have like a microcontroller, like this one, like this one that I have, which I haven't opened yet, but I want to play with it. You can install something called FreeRTOS. So that can go on devices that may not be as heavy duty, like a Raspberry Pi. And then from there, you could try delivering OTA updates directly from AWS to this microcontroller running FreeRTOS on it.
Yeah, and I would be interested in seeing like if there's any SaaS solutions that already have that baked in, and how this would actually be affected depending on if you choose a Raspberry Pi or a Arduino device as well. That might impact. But yeah, thanks for that participation, everyone. It's been great.
I do want to add. Do you mind adding the FreeRTOS link to the banner?
Yep.
Let me send it to you. Yeah, and like I mentioned, if you even look at the briefing on FreeRTOS, it's for any resource-constrained devices. I don't have the stats off the top of my head of what makes sense, but we should be able to share the link for that. And then over the air lets you deploy the firmware updates directly when you register them with AWS IoT. So it is a similar pattern to this one, where like even though this thing is smarter than this microcontroller that I have, the whole process of registering them is very similar. And then once you have that, it is a very similar way to deliver the firmware updates from the cloud to the lock.
Great. We had a comment from Babish saying we have been using free RTOS on ESP32.
Oh, yeah, that's I have ESP32 right here on my table. I'm looking forward to diving into it and playing with it and maybe demoing some of the stuff we learned in the next episode or later episodes, because some of our colleagues have lab setups already that are probably way cooler than what I can do. So we want to bring them in to talk about it.
Yeah, join us on future episodes. We'll definitely be more involved in terms of hands-on type of streams. So
cool. Oh yeah, and to the question about like the firmware updates repository, I guess in this case, Amazon S3 is serving as that repository under the hood. And that's how we're delivering it. I know there's other ways to deliver firmware updates, but in this context for AWS, we use S3 here.
Babish also mentions try with USB IDF or simpler Arduino.
Interesting. What kind of projects are you building with that setup? We don't have to wait for the response.
Yeah.
No pressure. No pressure.
No pressure, Babish.
Yeah. We're just curious. Okay. I mean, we've got 8 minutes. We could try to blitz through no, maybe not. I always want to blitz through things. I mean, we could. Let's see how far we can get in 4 minutes about showing people maybe what it looks like if you have a broker. Okay, so we have a local broker and we have a smart lock, but we may have other devices. And so what did we want to talk about is a broker in your house, like an Echo, is meant to try to register a bunch of devices. And so you can manage them in one place and potentially locally. Like if you lose connection with the internet, maybe you want to maintain functionality. So say you wanted to roll your own, I think Greengrass kind of makes sense to talk about it in that sense. But there's Greengrass is something that you can install on the Raspberry Pi. And there's different components that you can use. So there is an MQTT broker. You can also bridge this communication. And there's other components that can help you with translation as well. But the gist of it is, if you were to roll your own, there are ways that you can use Greengrass, and there's a lot of docs out there. Hopefully this gets some ideas going of how you might handle multiple devices and trying to handle them on your own in your home. I think that would be a cool project to work on. But the thing is, there are a lot of there's a lot of companies that have very full-fledged broker products, and with devices that all work together. So there's locks, and there are lights, and there are temperature controls that all interface well with Echo. And now, so trying to go with Matter, you can make your life easier by just looking at the products and seeing what protocols they support and what standards they're under, and then just making sure they mesh together. And one of the things would be if you had another vendor and you tried to bring a device under that one, there could be some limitations, right? So it may be able to register your temperature control, but it may not be able to adjust the temperature and other slightly annoying things of that nature, which is what makes the smart home market more complex today. And it's not an easy problem to solve.
Yeah, interoperability is always a tough one.
Yeah. One thing that you also want in your broker is this component for like called a spooler. And spooler sounds complicated, but essentially it's just like, what can I do to store data locally? And then when things are connected again, just like be able to forward the last known state of my devices. So like maybe you want to capture your device statuses, your shadows, and then when you connect online, you send it to the cloud. And then one last piece to represent, send it off to the cloud. So yeah, and again, a lot of this will be like topic based. So something to think about is how there's a lot of topics out of the box that'll work, and a lot on the IoT white paper lens doc of like what topics exist and how you might use them. And that's a lot of how you can think about how the flow of information will happen from one side to the other. Okay.
Great job. Got through, blitzed through a lot of there for 3 minutes.
Oh, one last thing. I know we got 3 minutes left. I don't want to leave this out because we are talking about some security stuff. There are things that there are other managed services in AWS IoT Core, or sorry, AWS IoT, that you might want to think about. So like IoT Device Defender. This is a managed service that helps you detect any anomalies that are happening with the devices that are in the field. And it integrates well with IoT Core. So in a lot of cases, you can just activate it and it will find, it will locate like suspicious behavior and it will generate like a finding. And if you want to integrate that with, say, your pure IT findings, like, those things that are like misconfigurations and stuff of that nature on the AWS infrastructure cloud side, plus all the IoT, all the device findings that you're getting, you can funnel that to, you can just consolidate all your security findings to something like Security Hub, which is more well known to like a lot of SAs. But just one more thing that you can do to consolidate security findings. Yeah. Kill switch. Would you consider using any ML model with the lock? For me, no. When I want it open, I open it, and when I want it closed, I close it. I think it could help. I mean, Chris, what do you think?
Not for a lock, but I definitely see that being more of a play for maybe like a smart fridge or something with cameras.
I don't forget to lock my door, but I guess if there are people that are very forgetful, maybe it's like after a long period of time, you can just lock the door. But then it feels like that ML might be over engineering there, because you could just assume it's like after an hour or like after 30 minutes or 20 minutes, if no one has done anything, maybe you could lock the door. But everyone lives differently, so it might make sense. I think it could make sense. Yeah.
Good question, though.
Yeah, that is a good question. Oh, I was trying to hide it. I know we've got 1 minute left. Do you have any? Okay, I'll just give a quick rundown of what we talked about today. We talked about how do we onboard devices, why do we onboard devices to deliver firmware updates, to have a maintainable process to help improve the product. We talked briefly about tracking the state of devices, and we talked about the concept of having like a broker try to consolidate a lot of disparate devices and handle offline processing. Yeah, Chris, what do you want to talk about in the next episode?
Yeah, we can take it many directions. Potentially, we're potentially looking to see if we can bring in someone that already has a lab environment set up to be able to showcase and go through, whether it be a light switch or whatever it may be, show in real time. And then we can also dive a bit deeper into kill switch's question in terms of ML model capabilities within a certain smart appliance as well, and what would make sense, how that flow would actually look like from an AWS perspective. So yeah, join us next time.
Yeah, thanks for chatting it up with us this week.
Thank you, everybody.
Next time. Bye.
Bye.